I will start with Google BigQuery itself in terms of our regular recommendations we would make. So for Google BigQuery, we firstly look at whether your queries are well optimized using BigQuery best practices. So what we would do as part of a cost optimization session is ask for access to the BigQuery resource as well. So we can do queries on your information schema and see where your busiest queries are and whether they are well optimized or not, because it is common across a lot of our customers where a lot of queries are being ported directly from legacy SQL databases like SQL Server, and perhaps BigQuery has better ways of running those same queries. Like one example I see a lot of is row number being used instead of aggregation functions, which Big performs better with. So often it can be better to optimize your queries using BigQuery best practices in BigQuery to save bytes scanned and also slots utilized. So this is something we look at in the first instance. We also look at whether your tables are partitioned and clustered. So we recommend using partitioning and clustering for your larger tables where possible, especially where those are more heavily scanned. So partitioning in Google BigQuery splits your tables up into partitions so that whenever those partitions are used in where clauses, it will only select the partitions it needs to run the query. So you are scanning less bytes across your tables when you have partitioned a table in Google BigQuery. And then for clustering, that will order your tables by the cluster fields that you select. So this can be useful again where you have maybe a character field that's been heavily filtered. You could cluster that field and then it would make your queries again perform better in a lot of circumstances. So it's always good to use partitioning and clustering where possible on larger tables especially. We also then look at how your current partitions and clusters are enforced in your queries. So one thing to make sure of is if you have applied partitioning and clustering on your tables, to make sure that they are actually being used in your queries, because if they aren't, then you aren't really getting the cost benefit from those partitions and clusters. So we always need to make sure that they are being enforced in your queries. So that's another recommendation. We also like to check your priciest queries and make sure these are not running too often. So basically making sure that if you have a job that maybe is running 3 times a day, but it could be refactored to only run once a day at a cheaper cost than it is to run the same job 3 times, we often recommend that certain queries are rescheduled or refactored in a way where they can be run more incrementally, a less often basis, to make sure you aren't paying for as much in terms of bytes scanned and also slots utilized in Google BigQuery. We also look at making sure your query runtimes are managed across the day. So if it is possible where you don't have a particular time limit on a given query, it's often better to split your workloads out throughout the day to reduce the strain on BigQuery and also your slots utilized. So whether you're on demand, you still have a limited number of capacity even when you're on demand in terms of queuing, which could cause queries to queue. So we always recommend splitting your workloads over the day to reduce the impact of that happening. We also recommend backing up and deleting any unused tables. So if you have any tables in Google BigQuery that you are not querying on a regular basis, it's actually cheaper usually to store those within Google Cloud Storage usually, or delete them altogether. You do have long-term storage within Google BigQuery, but the price rate of that is still more than it is to store data in either archive, cold line storage classes, or just deleting them altogether. So it's always important to make sure where you have tables that aren't even needed to make sure they are either backed up into GCS or deleted altogether. And then another thing we look at is streaming inserts and whether you need to use them, because streaming inserts in Google BigQuery are at an additional cost to batch loads. So if you do not really need data in real time, we usually recommend that, again, streaming inserts are looked into as to whether you actually need the data to be streamed into Google BigQuery or whether you could do a batch load mechanism into Google BigQuery to save a lot of money in terms of data load. And then after that, we then look at BigQuery Editions recommendations. So on the Google BigQuery Editions side, as you may all be aware, Google BigQuery Editions was introduced at the start of July. And the things we look at for Google BigQuery Editions are your compute and your storage usage. So one thing that we do first off is we check how sporadic your compute usage is and what your average daily compute usage is over each minute of each day to go into the actual performance of your Google BigQuery instance as it is currently and whether Editions is worthwhile for yourselves. So we look at basically your entire workloads to make sure it's suited to an editions model, because in a lot of cases, if you are not spending enough money in Google BigQuery, it's often better to stick to the on-demand model, because you get usage of enough slots anyway with on-demand, and also you're only paying for the bytes scanned with on-demand. Whereas if you were using, say, more than $10,000 a month in Google BigQuery, it's often better to consider an editions pricing model, depending on what features you need. So you have the standard BigQuery Editions model, the Enterprise Edition, and the Enterprise Plus. We look at your workloads to see what you are using, whether you're using any BI tools, whether you need any in-depth security features, and from that and your compute usage, we can see whether it's cost effective to use a particular editions pricing model or not. We also look at how consistent your workloads are. So if you're consistently using the slots throughout the day, this will also dictate whether it's worth using an editions model or not, because if your workload's very sporadic, like for a BI environment, perhaps like a Looker dashboarding environment, then it may not be as cost effective to use BigQuery Editions because of the sporadic nature of your slots, because even though you can use the slots autoscaler in Google BigQuery, that is it's run at a higher, it still would in many cases be more costly than using on-demand pricing. And also the autoscaler can be quite aggressive as well, in that it autoscales by 100 slots at a time. And also you pay for a minimum amount of time for each slot autoscale as well. So it's also worthwhile looking at how sporadic your workloads are for that purpose. We then look at basically which editions model is best for you in terms of, as I mentioned before, the features. So if you do not need any BI workloads and you're happy with basic functionality in Google BigQuery, the standard edition could be worthwhile considering. Whereas otherwise, if you are using BI engine constantly or any particular larger features, then Enterprise is normally what we would go with, which comes at an additional cost to the standard edition. And if you need very in-depth security, FedRAMP risk requirements, then we would also recommend the Enterprise Plus. But again, that comes at an extra cost. We also consider your storage usage. So in terms of storage, Google BigQuery Editions has released the new physical storage capability, where you are charged based on the compressed amount of bytes that you have in your BigQuery tables, as opposed to logical storage, which charges you on uncompressed bytes. So for that, we need to look at the compression ratios of your data. And from that, we can work out whether physical storage is going to be more cost effective for you or uncompressed storage, because they are charged at different rates per byte, with compressed storage charged at double the rates. But if you have a compression ratio of greater than 2:1, you will save money on using BigQuery physical storage for your data sets. But another thing to consider is time travel and fail-safe costs, because as those are factored into physical storage, they aren't factored into logical BigQuery storage. So it's always worthwhile checking how much time travel data you need and how much that's likely to cost. So these are all things we look at as part of our cost optimization sessions.